Hello, everyone, and thank you for joining us, and welcome to the latest D-Zone webinar. My name is Jason Cockrum, and I'm the Community Engagement Manager here at D-Zone, and we're glad you're with us today. We've got a really relevant and an exciting topic for you, and so we're happy that you've joined us. If you're new to D-Zone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of knowledge resources for developers and anyone passionate about software development. We've got everything from ref cards to trend reports and thousands of articles written and published by our community every day. And so all of this makes us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like this one today. And you can find all of them at dzone.com/events. We've got things like fireside chats, virtual roundtables, webinars, and who knows, you might even see us at an in-person event later this year. So be sure to check out dzone.com/events for all that information. Today, we're going to be talking about a pretty big potential vulnerability in the software development lifecycle, right? We all know how important software supply chains have become. They're an integral part of developing software. And because of this, they've become a huge target for attack, meaning that the software that we're developing can be at a huge risk for our customers if we don't ensure that they're secure. So today, we're going to talk about that. A big part of our securing our supply chain is where we build it. And so building it on things like Azure can make it easier to manage and more scalable and more secure and things like that. So today we're just going to talk through some of the tools and best practices for securing that supply chain to help us build better, safer software. Joining me today is Marcus Hogue, the Senior Director of Solutions Engineering for Jfrog. He's a tech industry veteran of more than 20 years of experience in leadership roles at Heap, Lacework, AppDynamics, BMC, and more. He's been around. He's also an accomplished pianist, so maybe one day we'll get a concert out of him. You never know. Here at D-Zone, we are all about community, so we encourage you to get involved and to get engaged in the conversation. On the right-hand side of your screen, there's a box where you can chat with some of the other attendees and talk about your experience with software supply chain and maybe some of the issues and challenges you face. You can also submit questions if anything comes up during the presentation or even during the demo later on, and we'll do our best to answer as many of them as we can. We're also going to have a couple poll questions pop up, so be sure to get engaged with that, give you a chance to kind of get involved. And at this point, I'm going to stop talking and turn it over to Marcus. Marcus, take it away.
All right. Thank you, Jason. I'm super excited to be here with D-Zone today. As you were saying, right now, everybody is building their companies, their brands on their software supply chain. Software runs the world. And as we've seen, starting with SolarWinds or even going back, attacks like Log4j are specifically attacking the software supply chain. And what that means is that we've got a very, very complex pipeline of tools that are chained together, as well as processes and people that can put our companies at risk. So Jfrog and what we're here today to talk to you about is all about building a secure software supply chain and doing that on top of the Microsoft Azure platform in native as well as hybrid or even multi-cloud ways that are going to be relevant for you, your teams, and your companies. So in today's session, I want to make sure that we keep this interactive. Jason is really great about building this community, and I want to make sure that we're doing this in a way that feels real and authentic for all you folks. So please use the chat box. We'll have some polls and other interactive portions of this session. As you have questions, if you have questions in real time, put them in chat. We'll try to address them as quickly as possible. If you don't, if you think of the question later, we will leave some time at the end for some Q&A as well. So our goal again is that you go away with thinking about a blueprint for how do you secure your supply chain, all the way from shifting left to letting the developers see the vulnerabilities and the things they need to make software in a smart way, to running or shipping right in production and doing that in a way where you can feel confident about the software that's running in production. So again, I'm Marcus Hogue. I'm Senior Director of Solutions Engineering here at Jfrog. I've been in the software space for over 20 years now, which feels hard to say, but I'm excited to have been in this industry. I'm in Silicon Valley now, work out of our headquarters in Sunnyvale. So get to work with a lot of exciting companies that are doing everything from deploying SaaS software to deploying software in vehicles, or even military equipment. And the concerns all along the way are very, very consistent. So what we've heard and what we see with our customers is that managing your software supply chain kind of feels like this. Your head's down, you're getting your job done, and you look over to the side and you see there's kind of this fire happening, but you got to keep going. You can't focus too much on it. So we want to talk about how do we address this? My first question for the audience today is what are you most concerned about in your software supply chain? You should see a poll pop up here, and I will share the results of this poll. I'm very, very curious. I've talked to architects from various cloud providers. I've talked to developers, DevOps managers, AppSec teams. The answers are always a little bit different, but I want to see, what do you folks think? So, is it open source software or third party libraries in your supply chain that you can't control? Sometimes that even includes the licenses that are included there. Is it the runtime security? How are you going to keep your environment secure once it's up and running in production or in that device? Is it exposed secrets getting out and then people being able to get access to your production environments? Or is it social engineering attacks? Maybe it's something other. If it's other, put it in the chat box there at the side. All right, I'm going to submit my own answer here. And Jackie, can we share the answers with the audience if we have a few responses? Let's see. We should be getting the answers any second here.
Can you see the poll that was closed?
Here we go. Yes, I got it. Thank you.
Right.
All right. So 50% of you said that it was open source software, third party libraries, 17% runtime security, 33% exposed secrets. That is very, very consistent with what I've been seeing. Not so much the social engineering attacks. That's a part of it, but unless you're Kevin Mitnick, that's probably not your go-to. There's way easier ways of doing these attacks now, especially with bots and automation. So, open source software is what I've consistently seen people's most worrisome aspect of the software supply chain. And the reason for that is that most software is comprised of 85 to 90% open source components. So if you think about your code at the tip of the iceberg here, we've got the APIs, the libraries, the base images, the operating systems, especially if you're including something like a Docker image. All of that is what your code is running on top of. And it's really hard to get visibility into where might there be a vulnerability within that. So we'll talk today about how do you get your hands around that problem of open source software. One of the best quotes I've seen is Dan Lorek said, every time you do pip install or go get or mvm fetch something, you're doing the equivalent of plugging a thumb drive you found on a sidewalk into your production server. And if you think about it in that terms, that's something you never do in an actual data center. But we find ourselves doing that all the time with open source software today. So it kind of puts things in perspective for us. And so that's where software supply chain attacks usually start, is that often it's a malicious package or unmaintained package, or like Log4j, a package that was fine for a period of years, but all of a sudden now it's not fine. And we need to find a way to find out where that's in use or how do we remediate that. I don't need to read all of these. You folks have seen these things like hackers exploiting GitLab, unauthenticated remote calls. Facebook has been compromised. GitHub repositories are where so many bots go and steal these keys. A former a company I was at previously, we had a number of companies we worked with where they would call them the smash and grab, where somebody would go grab your Azure access tokens and then use that to spin up a ton of high workload instances and just mine a bunch of Bitcoin. And in a matter of hours, they can rack up six-figure bills and then they're gone before you know it. That's all happening in an automated way. And so we need to be designing our supply chain in a way that takes these things into account in real time. And so we know that this problem is not only important, but it's an expensive one to fix. So vulnerabilities in third-party software cost companies $4.5 million in 2022 compared to 4.3 million in 2021. This is not cumulative. This is per company that they're going and remediate. And we know that the further this gets out to the right, that this gets into production, the harder it is to fix and the more expensive it is to fix these sorts of issues. In 2022 alone, there was almost 21,000 CVEs registered. As a note about that, Jfrog ourselves, we're a CNA. We publish CVEs. We have a very deep research team. I'll talk a little bit more about that here later. So I've talked a little bit about this problem. We know that supply chain attacks are the thing that keeps a lot of us up at night. Just to kind of wrap up this portion of the conversation, I'm going to ask for your interaction again. How much do you think software supply chain attacks have increased in 2021 alone? So you'll see a poll pop up here. So do you think it's 50%, 80%, 150% more? I'll give you folks, just a few minutes to respond here. I'm going to submit what I think it is. See some more coming in. Great. All right. We'll, once I get one or two more responses, we'll close this. All right. Okay. Thank you, Jackie. So what the response was, nobody thought that it was 50 to 80%. You folks are right. We had about 45% of folks think that it's 150%, 55%, 56% actually, think that it's 300% or more. And I hate to be the bearer of bad news. It was twice that. So there was a 650% increase in software supply chain checks in 2021. And then in 2022, it went up yet another 40%. So there's this hockey stick effect happening with software supply chain attacks. So I'm not just all about the bad news. I want to talk about how does Jfrog approach this? How can you approach this with your companies and thinking about securing your supply chain? So the first thing that we do is we take an end-to-end unified platform. We take that thought that we need to start in the developer's IDE. We need to be providing a repository where people can go and get the packages, the NuGet packages that they're using today, or NPM or Maven, whatever they are using. We want to work with the tools that the developers are using and not ask them to do something unnatural or add more things to their process. We think that automation is a huge approach, is a huge accelerator for everybody. So we want to do as much automation as possible, make that possible through things like CLIs and pipelines, and not lock anybody into a single cloud. So while today we're talking about Azure, many of our companies, our customers want to take a multi-cloud or even a hybrid cloud approach. So in the hybrid approach, they've got perhaps some repositories that are self-hosted in their own data centers or in their private clouds, as well as they're extending that out to Azure and using parts of that native within Azure. And we can support that sort of architecture, of course. It needs to be scalable across all the organization, and it needs to be trusted and secure. Um, Ultimately, if I'll just wrap this up, is that if we don't make a platform that can move securely at velocity, you folks know that it's going to be something that ultimately nobody's going to want to use. So where are the vulnerabilities and where do we focus on securing? If you look all the way to the left of the software supply chain, this is where we have the public repositories that are feeding into the developer. They're running the npm install whatever package. And then from there, they're creating their builds and publishing it. And it goes down the line with DevOps ultimately into production. So the areas for exploitation along the way are really, really high. There's threat actors all the way from injecting malicious packages to 0 days and being able to find those sooner rather than later. If we're not finding the 0 days, somebody else is. Exploiting known CVEs to stealing secrets, abusing misconfigured services. I know this is not an AWS talk, but I know that people are probably familiar with what happens to companies when they've got an open S3 bucket, for example. Those sort of misconfigs put customer data at risk. Tampering with binaries or attacking in production. So each one of these has different threat actors focused on this, and each one of these probably has some automation on the attacker's side targeting these specific things. So what can you do? What does the solution look like? Is let's start with how the developers get the packages in the first place. So the first is a curation. So curating the packages from the public repos and creating policies to say, all right, if it's this license type, that's fine. If it is a N-1 version, that's fine. I don't want people using the edge releases. You can create your own policies or even curate and create policies to say, based on what we define, this is always allowed, never allowed, or needs manual approval. I'll give you an example of that. I was just working with a customer the other day, and they said that MIT licenses are really problematic for them because every MIT license has a very specific copy holder. It's not always, it's not like the Apache license where it's the same. It's MIT license copywritten with the author. And so every one of those needs to be reviewed. And so they're curating the packages that come in based off of the specific MIT licenses. So the public, so curating the packages that come in from the public repo, that ultimately goes into your Git repository. And then we provide capabilities along the way to be able to manage this as it goes into build. So starting with the IDE integration, I'll show you today what that looks like in VS Code so developers can get the view that they need in the tools that they're used to of, are they writing things in a best practice, or are they introducing vulnerabilities into the organization? Then we need to resolve those dependencies. There's these transitive indirect dependencies that can be creating risk that we sometimes don't think of. So we'll show how do we understand what transitive dependencies might be bringing in risk and how did they get introduced in the first place. Detecting it's not enough. Knowing where it came in and how to remediate that is really powerful. Then we want to store that in a secure platform. Artifactory, which is what Jfrog is most known for, is a artifact repository. And so what we do is that we are a centralized place where all of the packages that you use to build your software, as well as the builds that you create yourself, can be stored in a secure way that's very cost and storage efficient. And again, this can be running natively within Azure. That is something you could be doing through the marketplace today. Now, storing that is great. This is where the build happens. And then you need to be able to scan these builds as well as these packages. JFrog X-Ray is our capability that allows us to scan this. And then pipelines can be used to distribute as well as create builds, or you can use Azure DevOps, which I'll show you today, or Jenkins, or whatever your tool is. The point is integrate it with your pipelines at each step. So your builds are going into a secure repository. You're continually scanning for risks, as well as then pushing that out to your endpoints, whether those are IoT devices with capabilities like Connect or distributing out to multiple sites. Many people are starting to learn about S-bombs. I'd be curious, just put it in chat, like if you're generating S-bombs or if you're being asked to generate S-bombs today. This is something that we've started doing as well, and we found that it's very important. We're even getting asked ourselves from federal agencies as JFrog to provide an S-bomb, which is a software bill of materials. So if you haven't heard that term yet, I guarantee you will within the next year. The software bill of materials is the if you think about software as a entree, the software bill of materials is all of the recipe, all the ingredients, and how you make it, how the software was made in the first place. I'll show you how to generate an SBOM today. And then pushing that out with signed releases and signed pipelines is ultimately going to give you the security and the knowledge that what we deployed in production is what we built in the on the developer's laptop, and nothing tampered with it all along the way. We had an immutable release. So I'm going to pause here before I go too much further. I saw one question in the chat. Bob was looking for some docs. I'll give you a doc here, Bob. And it depends on what you're looking for. I will give you more if this is not exactly what you had in mind. So if you're thinking about the JFrog platform as a whole, if you're already using JFrog, I just linked the root of our documentation. This gets you to our wiki, which has all sorts of things. If this is not what you're looking for, I'm going to give you some more specific links along the way, Bob. But keep the questions coming and let us know if this is what you're looking for or something more specific. So the capabilities that JFrog's introducing here, we talked about SBOMs, the ability to look at licenses, operational risk policies. I'm going to show you that in a moment, malicious packages, and identifying vulnerabilities. And this is all made possible through our composition analysis, software composition analysis, or SCA. And this helps us identify what are all the pieces that are making up this software, and does this meet our defined policies? So detecting malicious packages is key. And JFrog here, we have a catalog of over 165,000 malicious packages. And this is really driven by our research team. I'll share in the chat here a couple interesting examples of the type of research that we're doing. So the first is, well, both of these examples are related to NuGet. So the first is the Impala malicious NuGet package stealer. And then another one around how attackers are targeting .NET developers specifically with malicious code. So both of those be interesting research for you to read. And the important thing to understand about that is that this is the type of thing that's coming from our research team. Our research team came from an acquisition a number of years ago. And again, we are a CNA, meaning we research and publish these vulnerabilities ourselves. So what does the advanced security do on top of everything we were talking about with SCA? One, it provides contextual analysis. So contextual analysis helps you understand where is this applicable? Is this service even running? Secrets detection, which quite a few of you mentioned was a concern, and application library misuse or misconfiguration. And then ultimately things like IAC security analysis. Is this Terraform module that I've written, is this going to create concerns within, or is this going to create a misconfiguration running in production? So I'll share a link here to the to our research team. One of the great things about our research team here at Jfrog is that, one, we've done all of this analysis. We're also publishing and sharing tools back with the community, but we will also take research requests. So if you're in the Jfrog interface and you say, hey, I want the research done on this package, nobody knows anything about it, but I suspect something is amiss here, you can submit the feedback request directly within the package, the platform itself. And the reason that we think that this sort of analysis is important is, if you look at NVD, for example, to the National Vulnerability Database, just looking at the criticality of the CVE does not give you enough information as far as where do you go fix something, or what should you prioritize first. That can lead to a lot of wasted effort and wasted development time, which we know that you don't have. So what we've done is we really looked at applicability of these vulnerabilities, and we found things like, it turns out that 78% of reported common CVEs and Docker Hub images aren't even exploitable. Well, why is that? Part of it is that the tokens have been aren't even active anymore. As well as secrets detection, we use Yara, which is a common pattern definition. We have over 250 Yara patterns, and we're continually releasing more. And the goal here is to eliminate false positives. We don't want to tell you that something is vulnerable if that service isn't even running, for example. So again, our research team is really driven around what is the real threat to you, not just pointing out that there's a bunch of CVEs that are rated 9.8. So this is what I was hinting at, is that if you look at the number of inactive access tokens versus active tokens, this is where we can see that, yes, well, there were secrets that were shared out in these Docker images. Most of them aren't even active anymore. Now, you could say that's a good thing. Now, the other 50% that are still active, that's probably even more concerning. So we have to make sure that we find that. The last thing before we jump into the demo here is we recently did an analysis with Forrester, and they published a report. I'm going to share a link right here to the blog about this, about the total economic impact, or the return on investment, that Jfrog customers have gotten by implementing this platform, this end-to-end platform. And what they found is that it's been a 393% return on investment, with a payback period of less than 6 months, meaning the software pays for itself in less than 6 months. The quote I love here is, the Jfrog software supply chain gives us a lot of resiliency with our source code that we wouldn't otherwise have. It's an anonymous quote. I can't tell you exactly who said that. So where does that impact come from? One, accelerated development time. If we can make your builds faster, because your build systems aren't having to go fetch remote repositories, instead we keep them cached local to where your build systems are, we can speed up your build times and make it that much more productive for your developers. Second is the automation of vulnerability and compliance activities on open source software. So automatically scanning those packages as you're bringing them in, or in real time, or even better yet, in the IDE. And then this creates increased productivity with the whole DevSecOps collaboration. I've seen time and time again that if the security team brings in a tool and says that developers need to use it, that's going to slow everybody down. And then vice versa, if the developers bring in a tool, but the security team doesn't bless it, that's also, they're not going to get credits for having those controls. And it leads to tool sprawl. So one team is using one tool, another team is using another tool. Instead, what our customers get is having a standardized set of tools that developers love, security loves, and it creates a much, much easier platform. a much easier life for everybody. So with that, I'll jump into demo. I'm going to take a quick look at chat to see if there's any other questions before I do. Um, and then we will switch into demo.
Real quick, Marcus, before we jump into the demo, which I'm very excited about. I think Jackie was talking to Bob, trying to get the docs, and thanks for sharing those. Bob, and for anyone else, if you're request or asking about docs specifically for the webinar, like the presentation, all that stuff, you will all get that as soon as the webinar is over. So if that's kind of what you're looking for as well, all the attendees will get that once the webinar is finished. So I just wanted to touch on that real quick. All right, let's do a demo.
Perfect. All right.
And you can still continue to ask questions during the demo. Sorry, didn't cut you off. Real quick, yeah, please feel free to ask questions that come up during the demo. We'll give a few more minutes at the end to answer any other questions. So now you may take it away.
Yes, thank you, Jason. So as I get into this demo, I also want to share some resources with you folks in case you want to follow along. So if you already have, if you have Artifactory and you have Azure, the link I just provided to you will help you get started with this. So it has a link to the Jfrog extension directly within the Azure Marketplace. So these skills that I'm going to be showing you, you can enable these right within pipelines today. So where we start our journey is within the pipeline where we're building. In the example I have today, this is an NPM build that I'm doing. And within here, you can see I've got a number of builds. We'll look at what is the result of these builds. But I first want you to understand how easy it is to add Artifactory to your build as it is today. So this is my pipelines YAML. And you can see I've got a number of skills here, or tasks, I should say here, like this Artifactory build that happens. And let's say, for example, I don't have any security scanning happening within this. And I also want to compile a Docker image. I can just go to the Artifactory X-ray scan, add this, select my Artifactory service. You'll configure this when you configure the plugin. And if there's a specific project key, all this will do is say, as soon as I'm done with this build, run my scan. Otherwise, it'll be on demand, or I'm publishing this to a repository that has automated scanning built on it. So that was one of the things that we talked about, enabling automation and doing it in a way that's very compatible with the way that you're doing it today. The other could be, once I'm done with this, I'm going to build a Docker image, and then I want to push it to a repository where other folks could get this. Again, another example of how easy it is to add these tasks within your YAML files you have today. All right, I'm not going to make these changes. So let's now take a look at this build. So this is a build I ran not too long ago. And of course, we would have been able to see the job happening in real time here. But what I'm interested in is what happened, or what was the results of this build, and was it a good build? Are there security risks here? So right within Azure pipelines, right here, I can see I've got a link specifically to this build. And now I can go to the modules that were published as a part of this. So in this pipeline, I'm a Node.js person, so I'm using a lot of NPM examples today. I hope that works for you and you can follow along. I've built this NPM example with 148 dependencies. All right, great. What are those dependencies? Well, it's all of these. So I'm including accepts and after and array flatten, and there you can see there's 19 pages of dependencies here, and these are all the things that just got pulled in because I'm pulling other npm packages which all have transitive dependencies. This is helpful information, but it can start to feel really, really overwhelming to have all this information. So that's where X-ray comes in. And so with X-ray, the first thing we can do before we spend even too much time thinking about it is if somebody wants to understand, can you tell me all the dependencies and everything that's built in? I can export this as my SBOM. So my software bill of materials that we were talking about just a moment ago, this is exactly what it'll look like. So with the SBOM, I will get a list of all the packages. Are there CVEs related with these packages? What the applicability is with it in everything? And again, that is something that's just one click away. We have many customers that are just doing this via the CLI and having this be part of their build process. So I can start to sort this and understand what vulnerabilities may exist as part of this build. So I can see a number of critical vulnerabilities, and I can click on these and get more information about these vulnerabilities. And this is where the Jfrog research starts to come in. So each one of these vulnerabilities, if they're critical, you'll see the difference between the CVS score and the NVD score as well. I also mentioned that for some customers, the license types are big concerns, and they want to understand what licenses are included in this. So in this one, there's a number of MIT licenses. I also have customers that have defined their own license format and know that when those are included, or third party where they have to pay royalties on those licenses, they use this to find those as well. The last part about this build that I think is really interesting. So we've looked at, are there CVEs that are applicable to this build? But the last thing is what is the operational risk? So this shows you, is there risk just including these packages because maybe it's not well maintained, or maybe the package has been abandoned at some point?
Hey, Marcus,
Yeah.
quick question for you, just for my own clarification. How does JFrog define operational risk? Like, what are you guys flagging as operational risk in this process?
Yeah, it's a good question. So you can see some clues from the headers here, but I'll actually pull this up, this document, and let me share this with the folks in chat as well. So here's all the components we look about for end of operational risk. One, it's things like end of life. Has this package been end of life? That in and of itself starts to increase the risk. The version age. So how old is this specific version that you're using? The number of new versions since then. So how many releases out of date is it? As well as the health of the OSS project. This, I think, is almost the most important, is the project health itself. So what is the release cadence, the number of commits, number of committers? So if there's been 0 commits, 0 committers for 3 years on a package, and last release was in 2017, that's how we're thinking about the operational risk. It doesn't matter if there's a CVE or not. The risk of a 0-day being found on that package goes up a lot. Does that answer your question, Jason?
Yeah. Thank you. That's actually really interesting. It's like having your own team of security analysts without having to pay extra for it. But I really like the health of the project. That's pretty fascinating, and it makes a lot of sense, right? Like if there's hasn't been any recent commits or anything, like you don't really want to use that project, right?
Exactly. So it's about putting yourself in the both the shoes of the developer as well as somebody with a community minded nature, and the security team themselves, that AppSec for person.
Right, and it's nice too because it's helpful that you can another level of verification you can provide to your customers and show them like, hey, this has all been scanned, like this has all been analyzed, like our pipeline is secure, and you can prove that if you need to your customers. So that's really cool.
Exactly. So what have we done so far? One, we took a look at a pipeline, and we looked at the build that came out of that. We looked at how we could add things like the security scanning as part of that build, or other actions like pushing to a Docker repository. I'm going to take a step back put ourselves in the shoes of the developer and look at what would it look like from the developer to be able to make some of these decisions before the build even happens. And then we'll then move a little bit further down the pipeline as far as what if we compiled this into a Docker image and what vulnerabilities might we be introducing there. So uh, again, I'm a Node.js person. So this example here is some really bad Node.js that I wrote a couple years ago that I've not updated. If you go look in npm repository, it is really out of date. I've not committed to this thing in years. So what is the biggest thing to see is, one, we highlight right within VS Code here, specifically where we're including packages that have CVEs related to them. And then anywhere you see this little green research icon here, that means that our research team has done additional analysis around it. So if I look at Lodash as a transitive dependency, I know it's transitive because it says indirect here. So another package is bringing it in. Well, there's a number of CVEs, but let's just start at the top. Insufficient input validation in Lodash leads to prototype pollution. What is the remediation? This is everything that our Jfrog research team is providing. So this is specifically how to remediate this, as well as specific details. What is our research severity reasons? So there's a little comment here that Jfrog research is different than NVD information. We're publishing additional information above and beyond. Why do we think that this is maybe more critical or less critical? This is more critical because this issue has an exploit published. There's a proof of concept out there that uses this exploit. So this is really bad. We would want to start with prioritizing this. Well, okay, great. But if I look at my dependencies, maybe I did not explicitly include Lodash. So how the heck did this get included in my code in the first place? That's where I can look at the impact graph, and I can see that this mini node bot workshopper included gulp, and gulp included vinyl. Vinyl included globwatcher. Globwatcher provided gaze to globule, and then that to Lodash. So you can see all of these dependencies that get pulled down, just including one library. It's not just that library that you're including. It's all of those transitive dependencies that get resolved, that in the build of the package, that's where the risk ultimately gets introduced. And if we can show this to developers in VS Code as they're developing in real time, the chances are they're not going to either include this version or include this library. They'll look for alternatives, and we provide the research right here as far as how could they remediate this right within their own code. Here's some copy paste code. Now you have the ability to fix it yourself, Mr. or Miss Developer. And this is one less thing that gets flagged when we get promoting to production. So I mentioned that I was going to skip ahead a little bit. Now, let's say I built this NPM package and I'm going to deploy this to production. As part of that build, I build this into a Docker image. Well, that Docker image, base images often will have additional things in them that I might be concerned about. So first, we can look at the policy violations and see where we've already violated policy. This could be CVE criticality violations. These could be license violations, or we could look at other security issues. So I was talking before about how do I know if this is even applicable, or where do I start? This is one of the best things about the Jfrog platform, and what our research team provides is applicability. Stumbled over that word. Applicability of these vulnerabilities. So where would I start? I would start here with the ones that are most applicable. There are some 9.8s that are included as well. They're not applicable. Maybe the service isn't running. I don't need to waste time on fixing this Docker image on things that aren't applicable because the service isn't running or the library is not called. The other things when it gets into things like Docker images that are really important are finding things like secrets. These often get leaked within especially container images themselves. So where do I go and fix that? I can tell you exactly where it's being included and how to go change this. And the last could be things like services, misconfigured services. I've seen this time and time again with things like MongoDB, where the service is up and it's running, but now all of a sudden it's not using the right cipher, or it has no default authentication. So we need to apply those things. So I've talked now all the way from pipelines to the Docker image that may be running in production. I want to share a little bit now about how we could start connecting all of this end to end. So, especially if you're an Azure customer, you're here today, you're probably using Azure. One of the things that a lot of customers want to know is that, okay, if I'm using the Jfrog platform and I've got my own environment, how do I make sure that nobody can see my software be as I'm deploying it end to end? I need to make sure that it's immutable. This is one of the things we can do, is that we have the ability to set up private links between your own instance and JFrog itself. So we support all of the clouds natively. So Azure, for example, we let you select what region. So maybe it's US East, and that creates a private link that nobody will be able to intercept or even observe the traffic as it's flowing.
Wow, Marcus. Sorry, one other question too. This is fascinating. It's almost like having Chat GPT on steroids, right? Instead of creating your code, it's analyzing it, fixing it, and providing you the resources in real time. You don't even have to ask it. Like it's kind of where we're headed, right?
Right.
So like if I wanted to try this, right, is there a way I can kind of try it in my environment, test it out, see if it's working, and kind of proof of concept thing, and then share it with my superiors, kind of show them, hey, this is what we need.
Yeah. There's a couple ways. So I'm going to share a couple links here in chat. The first is you can start a free trial right here on Azure, and this will help you get going. You'll have access to the entire platform for a number of weeks. We have package support for over 30 different types of packages. If you don't see it, we've got generic support for different repositories. Again, what does that mean for you? Is that the tools that you're using can speak natively with our repositories. If you're running Docker pull, you can point it directly against Artifactory. If you're running Chocolatey, you can point it directly against Artifactory. So that would be one way to get going. Another way to get going is if you are an Azure customer and you want to learn more through the marketplace, here's a link to getting started directly on the Azure marketplace on this page, as well as a lot more information on how to scale your platform with Azure. So it talks about everything from Azure Resource Manager. How can you use ARM to even deploy JFrog itself? The VS Code integration I showed you today, AKS, if you want to store your Helm charts within JFrog, that's something you can do easily. More information to DevOps, the pipelines we talked about, and of course, Azure Active Directory. Many of our customers use Active Directory as their single sign-on with JFrog. So we take a very integrated approach, and we again want to make sure the technologies that you're using with Microsoft, Azure, or even other cloud providers, we support those natively. We make the integration as easy as possible, and we want to make sure that the documentation is all there for you as well. So whatever your configuration is, cloud, hybrid, multi-cloud, you'll find a way to get to your desired state there. So I think that's a good segue, Jason, to opening up for any final questions that folks may have on chat. We could take them via chat in the Q&A, or I don't know if there's private messages maybe you got in as well, Jason.
Yeah. I haven't gotten any at this time, but I actually did have one kind of further question again for myself. Is like, you talked about whatever environment you're on, right? Cloud, hybrid, multi-cloud, blah blah blah. Like, what would the process look like, or how seamless or difficult it would be to switch environments? Like if I'm moving environments, or if I'm adding a new environment, like what's that process like? Is it negligible? I mean, what would that look like?
Yeah, so from a work perspective, it's minimal work. So you turn on federation, let the replication happen, and it's just a matter of time and speed for how big of links you have to how long before all the data is there. Now, we've had customers that maybe they have had JFrog Artifactory for a long time. We started as an open source project, so there's lots of companies that have been using us in servers, started in a server underneath somebody's desk to now it's sitting in a data center. They're at now terabytes or even petabytes of data. If you want to migrate something like that, we do have professional services packages and a PS team that has a lot of experience in moving that over, because we have to think about availability to the developers and the pipelines themselves. So if we need to manage a cutover, we have our PS team that could work with folks on those sorts of cutovers. Short answer is turn on replication. If you want a little bit more complex, a consultative approach, our professional services team would work with you on that.
Cool. Well, thanks. Okay, yeah, I don't see any other questions at this time, but it's probably because everyone's so blown away by the awesomeness that they just haven't been able to gather their thoughts yet.
Jason.
If you do have any further questions, you can always follow up with Marcus. I don't know if he had his contact information up there, but you'll also receive this presentation after it's over, so you'll be able to follow up there. So if anybody does have any last minute questions, kind of speak now or forever hold your peace kind of thing, and we'll give everybody a little bit extra time back. If there's yep, perfect. So there's an email address right there.
Yep, I just put my email address in there, marcush@jfrog.com. You can find me on LinkedIn as well. Connect with me there. Happy to chat with you one-on-one, set up follow-on conversations as well.
Cool, thanks. And just out of curiosity, who's your favorite pianist? Do you have one?
So this I don't know if this is going to be a comment. I'd say Rachmaninoff.
Okay.
Like his hands are probably like I don't know how big his hands were, but I think he was some sort of mutant to be able to play some of his stuff. So Rachmaninoff it would be for me.
Interesting. All right. Good to know. Cool. And so again, as you can see, there's a link there on the screen too, where you can check out the free trial. Encourage everybody to do that. And Marcus, I just want to thank you so much for being here, for joining us today, for walking us through all the incredible awesomeness that is Jfrog. And so I encourage everybody to go check it out if they can. And a very special thank you to everyone who joined us. We're really, really glad you guys were here. Don't forget to check out our website, dzone.com/events. There's a ton of other great stuff happening there. Like I said earlier, we've got things like fireside chats and virtual roundtables and all kinds of upcoming events, webinars, live webinars, on-demand webinars, all kinds of good stuff. And again, let us know if there's an in-person event that you want us to come out to. You might be able to see us there later this year. Other than that, we really, really appreciate you guys joining us. So glad you can make it. Have a wonderful rest of your week, and we will see you guys next time. Thank you so much.
Thanks, folks.